Good morning. In this video, I would like to explain about small sample test. In the small sample test, I would like to explain about t-test for single mean problems. Now, let us see the procedure of t-test for single mean. So, we already discussed the sample test, the sample size n less than 30, then it is a small sample test. So, now in the t-test for single mean, we are having the sample size value n less than 30 and we are having the data of, we are going to check whether this sample size it has been drawn from the same normal population or not. So I am repeating one more time, this is what we are going to define it as the sizes. So population means the group of individuals, we call it as a population. So the population size, it should be denoted by capital N. Sample means a small portion of this population, we call it as sample. So now we are going to define it as sample size is denoted by small n. So now in the t-test for single mean, we are going to check whether this sample small n, it has been drawn from the same normal population or not. This is what we are going to check. So now, in this case, we are going to define about the 5 steps process. So the first step is null hypothesis. In the null hypothesis, we are going to check this small sample, small n, it has been drawn from the same normal population. So we are going to check the null hypothesis. It should be denoted by H naught. In terms of notation, we are going to write H naught is mu is equals to mu naught. It means that there is no significant difference in the given data. So whatever the data we are going to check, we just go with the same statement. We are going to write it as a H naught. Now, let us check the second statement, alternative hypothesis. The alternative hypothesis in the t-test for 2 mean is, so as per based upon the problem, if the problem is, if there is check that whether there is any significant difference in the data. So in that case, we are going to write H1 is mu naught equals to mu naught. So the type of the test, it will be a two-tile test. Type of the test, it will be a two-tile test. So in the introduction, we already discussed that in future the first sample size value is going to be greater than the second sample size, superior the second sample size. If that question is there, that type of questions are there, we are going to write the alternative hypothesis H1 is mu greater than mu naught. In that cases, the type of the test, it should be a right tile test. In the given question, we are going to conclude, we are going to compare the first observations is shorter than the second observations. So in that cases, we are going to write mu less than mu naught. That case, H1, it should be a left tile test. So now, let us see the third step. Third step, it should be a level of significance. The level of significance, 5% or 1% are the fixed values. So in the given problem, if they won't ask anything, if there are only they are asking to check whether the data is correct or wrong, or is there any significant difference in the data, we have to follow through 5% level of significance. If they mentioned anything at 1% level of significance, in that case only we have to choose the level of significance is at 1%. So now let us see the fourth step is a test statistic. So now we are going to discuss about t-test for single mean. So single mean means as per the given sample size, we are going to consider it as only one mean is there in the problem, then only we have to consider the problem belongs to single mean. So now in the given problem, if the data is there, so here what do you mean by data? It means that sample data. So what is sample data? The given problem, it contains sample size small n, and if you have sample mean x bar and population mean mu and standard deviation sigma, if the data is directly there in the given problem, we are going to take the test statistic is t is equals to x bar minus mu by s by root n minus 1. If all the values they directly give in the problem, we are going to write this is our test statistic. This is the formula, and it follows the degrees of freedom with t with n minus 1 df. So it means that degrees of freedom means the number of independent variates which make up the statistics. In order to make a conclusion, we have to choose the degrees of freedom. So now let us see here, if you have data, if you are having some xi values, if xi values are there in our given problem, then the test statistic will be, we need to find out all the values of standard deviation. So in that case, the formula of test statistic is t is equals to x bar minus mu by capital S by root n, and here also it follows t with n minus 1. Both the cases it will be n minus 1. Why? Because we are choosing, it depends upon n variables. N is less than 30. If n is less than 30, then only the problem belongs to t test for single mean. It means small sample test. So now, in the given problem, you are having only some certain type of data. You have some x values only, you have some sample size, and we have a population mean. But the thing here, you are going to finding out the standard deviation of the given problem based on these individual observation. So how to find out S here? S is equals to, we know the formula, S is equals to square root of 1 by n minus 1 into summation xi minus x bar whole square. So in this way we are going to finding out the standard deviation. So depends upon the problem, we are going to verify which formula we are going to apply for t-test for single mean. So for both the problems, you are having only one n and you are having only one mean is there in the given problem. So that purpose we are going to do, the problem is on t-test for single mean. So now, all 4 steps are completed. Now let us see the 5th step is a conclusion. So how to make a conclusion? Based on this, we have to check it as any one calculated t we are going to finding out. So the calculated value of t, if the calculated value of t is less than tabulated value of t, we have to accept h naught. So it means that we are accepting h naught means this sample small n, it has been drawn from the same normal population. We are accepting h naught. It means, or otherwise there is no significant difference in the given data. So whatever the data we collected, that is correct, we can go through to make an analysis. Now, if any case, if calculated value of t is greater than tabulated value of t, we have to reject h naught. So here, reject h naught means there is some significant difference in the given data. So now, here, to make a conclusion, to choose the level of significance, the alpha level is different in t-test for single mean. It's not like a lot sample test. Now let us see here, if the test it will be a two-tile test. If the test it will be a two-tile test, it follows t alpha by 2 and it is what? 0.025. It is based upon the alternative hypothesis. If the test is two-tile test, here alpha follows t alpha by 2, 0.025. If in any case, if H1 is a right tile test or left tile test, other than these cases, it means the test it will be a right tile test or the test it will be a left tile test, we have to follow 0.05 or 1% means obviously 0.01 level of significance, 1% level of significance or 5% level of significance at right tile or left tile, we have to follow the table value. And our conclusion is same, that is calculated t less than tabulated t, we have to accept our h naught, otherwise reject h naught. So this is the process of t-test for single mean. Now let us see the problem on t-test for single mean. A mechanist is making engine parts with axle diameters of 0.7 inches. A random sample of 10 parts shows a mean diameter of 0.742 inches with a standard deviation of 0.04 inches. Then compute the statistic you would use to test whether the work is meeting the specification at 5% level of significance. So now in the given problem, so after reading the given problem, you have to identify the sample size. Here they mentioned here it is 10. So the given value of n, so we have to go with the conclusion, the given value of n is equals to 10, n is equals to 10 less than 30, so the test belongs to small sample test. So now the test it is a small sample test of the given problem. So now we are going to consider what the given values you have to identify after sample. whatever the observations, that observations it belonging to sample observations only. So now the sample of 10 parts such a mean diameter. So sample mean, they have given the value of sample mean, it denoted by x bar. So the value of x bar they mentioned here, it is 0.742. And standard deviation, with the standard deviation, it means that they are talking about only sample. So sample standard deviation is denoted by small s. So small s is 0.04 inches. So now we are going to choose, they are asking, the given question is that work is, to test whether the work is meeting the specification or not. That is our null hypothesis, because we are going to check that question. So now let's go with the first sentence. A mechanist is making an engine parts with axial diameters. It means the given problem sample size n less than 30, and they mentioned clearly one mean in the problem, so it is of sample mean. So the first sentence it contains, it is of population mean, the value of mu is equals to 0.7. So now let us go, we are going to confirm this is the problem or t-test for single mean. So now let us go with the first step, null hypothesis. So what is null hypothesis? It is denoted by H naught. So we are going to define H naught is what in the null hypothesis of t-test for single mean, mu is equals to mu naught. The population mean it is having with the specified mean mu naught. So and our given question is, we are going to conclude whether the work is meeting the specification. So now we are going to define H naught is mu is equals to 0.7. That is, the work is meeting the specification. We are going to conclude taking the same statement. It means we are assuming the data is correct. So the work is meeting the specification. The work is meeting the specification. And in the given problem, if you observe clearly, they didn't compare any of the observation, and they didn't ask that in future it is going to increase or in future it is going to decrease. So they are asking only to check whether this product is meeting the specification or not. So now our null hypothesis, we are going to define this, and alternative hypothesis means the statement against the null hypothesis is called an alternative hypothesis. So what is H1? H1 is mu not equals to 0.7. It means that the test belongs to a two-tile test. So if it is two-tile test means the product is not meeting the work is not meeting the specification, or the product is not meeting at the specification. Now let us go with the third step. So the third step is the level of significance. So in the given problem they mentioned clearly the level of significance is at 5%. 0.05 means it is a 5% level of significance. So we are going to write the LOS is 5%. Now the fourth step, it will be a test statistic T is equals to, in the last process we define it as two formulas of t-test for single mean. If the entire data, the values are there clearly in the given problem, we are going to write the formula of T is equals to x bar minus mu by s by root n minus 1 follows T with n minus 1 df. Because here in the given problem we are having n is the sample size, and it consists of 10 observations in the given problem. So we have to follow 10 minus 1 is 9 degrees of freedom. We have to follow the table value. So now we have to substitute all the values in the given problem. That is what T is equals to. What is x bar here in the given problem? 0.742 minus the value of mu is 0.7, and the value of s is 0.04 by root n minus 1. So n minus 1 it will be what? 10 minus 1, it will be 9, and it follows 9 degrees of freedom. It follows T with 9 degrees of freedom. Now we are going to simplifying the calculated value of T. The calculated value of T is 3.15. So now to make a conclusion we have to follow the table value. The table value is what? We are going to finding out the fifth step, conclusion. So here the calculated value of T is 3.15, and we are going to conclude the table value of T, for n minus 1 df. So for n minus 1 df it will be what? 10 minus 1 is equals to 9df, we are going to finding out for this 9df at 5% means 0.05 level of significance. We are going to finding out the table value. So here, as per this table value, it means that left hand side we are having the degrees of freedom 1 to 9. We have the values on the upper part of the table. We are having at 5% or 1% level of significance. We have with a table value. Now let us see the table value. We are going to finding out with t with 0.025. Why? Because t with 0.025 means here the type of the test is a two-tile test. So when it is a two-tile test, we have to follow the table value is t with 0.025. The table value is now 2.26. Now let us see the degrees of freedom. Here we have to follow at the left hand side of the table value, that is at 1 to, see, let us see here 1 to, these are 30 observations because we consider the small samples as sample size n less than 30. So now for this problem we are finding out 10 minus 1 9df, it is on the left hand side, and we are going to finding out two-tile test. So for this two-tile test we are finding out at 0.025 level of significance. So for 9df 0.025, the table is 2.262. So in this way we are going to finding out a table value. Now we are going to conclude this, that is what, 3.15 comparing with 2.26. It means the value, it should be a greater value. So if the calculated value is now, if the calculated value of t is greater than tabulated value of t, so we have to conclude that therefore we reject h naught. So rejecting h naught means what we are taking here, the null hypothesis, the work is meeting the specification. So and we are going to conclude that, so and we conclude that the work is not meeting the specification. So we have to conclude that therefore we conclude the work is not, or the product is, the work is not meeting the specification. The work is not meeting the specification. So in this way we are going to conclude the problem of t-test for single mean. So if the data is there, we are going to follow the test statistic of t, and we have to check clearly whether the type of the test is two-tile test. It follows t with 0.025 alpha by 2 level of significance. We have to conclude the table value, conclude whether it is greater or lesser, or you are going to accept the hypothesis or rejecting the hypothesis. So this is a problem on t-test for single mean. Now let us see the problem on t-test for single mean. The heights of 10 males of a given locality are found to be, they mentioned 10 sample observations. Is it reasonable to believe that the average height is greater than 64 inches? And test at 5% level assuming that for 9df. It means that the given problem they already mentioned the table value also. So now here the heights of 10 males. It means that the sample size is 10. So if the sample size is 10 means it is belonging to small sample test, because 10 less than 30. So here the given value of n is equals to 10. We can conclude based on this it is a small sample test, and they mentioned small sample observations, and it is greater than 64 inches. So here it means that is it reasonable to believe that the average height is greater than, it means that they are doubtful whether this data is right or wrong. So it means that they also mentioned clearly the value of mu is equals to 64 in the given problem. So we have to first to set up a null hypothesis for the given problem. So the first step here, it is a null hypothesis. Is it reasonable to believe that the average height is greater than 64? It means that they are doubtful on the given data. So we are going to conclude the null hypothesis H naught is the average height is not greater than 64. We are going to write the null hypothesis H naught is same as whatever we are checking in the given problem. That is the average height is not greater than 64. Not greater than 64. So now let us see the second step is an alternative hypothesis, that is the statement against the null hypothesis is an alternative hypothesis. It is denoted by H1. So not greater than 64, it means that it is H1 is mu greater than 64, because the statement against the Null hypothesis is an alternative hypothesis, so H1 is mu greater than 64. Now let us see the third step is the level of significance. The level of significance I mentioned clearly it is of 5%, so we are going to write it as 5% level of significance. Now the fourth step is the test statistic. It means here we are having the individuals, 10 individuals are there. We are going to finding out the standard deviation. So the formula of t test for single mean is t is equals to x bar minus mu by s by root n. And here it follows t with n minus 1 df. Follows t with n minus 1 df. So in order to finding out the standard deviation, we are going to take a tabular form, that is need to finding out the value of x bar. And let us see the tabular form. We have x values, x minus x bar values, and we have with x minus x bar whole square values. So we are going to finding out of all these 10 observations. So now the value of x is 10 observations is 70 and 67, 62, 68, 61, 68, 70, 64, again 64, 66. Now let us count, these are 10 observations. So now we are going to finding out the sum of all these observations. It will be of summation x. Here it will be 660. 660. In order to finding out second column, we need to find out the value of x bar. So the value of x bar is equals to summation x by n. So it will be what, 660 by 10 observations. So the value of x bar is here 66. So now let us see here x minus x bar. 70 minus 66, 4. X minus x bar square, 4 square, it will be 16. 67 minus 66, 1. 1 square, it will be 1. 62 minus 66, it will be minus 4. Minus 4 square, it will be 16. 68 minus 66, it will be 2. 2 square, it will be 4. 61 minus 66 is minus 5. So it will be 25. 68 minus 66, it will be 2. 2 square, it will be 4. 70 minus 66, 4. 4 square, it will be 16. 64 minus 66, minus 2, it will be 4. And here also minus 2, and it will be 4. And let us see the last one. 66 minus 66, x minus x bar 0, x minus x bar whole square, it will be 0. Now you need to find out the summation of xi minus x bar whole square here. So the sum of all these observation of summation xi minus x bar, it will be 90. So after getting this value, now we are going to finding out the value of s first. So it will be the formula of s is equals to square root of 1 by n minus 1 into summation of xi minus x bar whole square. Just substitute the values whatever we are having. N is 10 observations in the given data, so it will be 10 minus 1, it will be 9. Summation xi minus x bar whole square, it will be 90. So we are going to finding out the value of root 10. So that is what we are having with the standard deviation. The value of root 10 is 3.16. So now to substitute all these values in the test statistic, the value of x bar is now 66 minus, and we have the value of mu. The value of given value of mu is 64 by the value of standard deviation is 3.16 divided by root n, it will be 10, and it follows with 9 df. This is already they mentioned clearly in the given problem, the table value. So now substitute all these values, we are going to finding out the calculated. So now the calculated value of t is 1. This is the table value of 1.833. The calculated value is now 1.9. So let us go to make the conclusion. The fifth step is the conclusion. So now here this calculated 1.9 is greater than the tabulated value of 1.833. So it means that we are going to reject H0 because this calculated is value of t is greater than the tabulated value of t. So we are going to reject H0. So what is our H0? Average height is not greater than 64. This is what we are taking our null hypothesis. So we have to conclude that you are rejecting H0 means average height is greater than 64. average height is greater than 64, it means that there is some significant difference in the given data. So in this way we are going to finding out the conclusion of the t-test for single mean. Thank you.